sensors, which is really, really cool. It's just like to me, it's just fascinating technology. You send out a sound, and then you receive it. It bounces off. It bounces off some object, and you receive it. So it's that's the basic premise of it. But we'll get into that later in a little bit. But first, let's talk about make sure your Pi is on and running. We got to check this, or whatever computer you're going to use. If you're going to use a computer for your Arduino, that is perfectly fine as well. So let me see a raise of hands to see who has their Pi up and running. So Austin has his Pi up and running. A couple of you do. So I'm going to hold off for a little bit. All right. So make sure your Pi is up and running. And while we talk about that, I'm going to get my Arduino out. It's not all hooked up, but I'll go through the lesson with you, and we'll see. So, so anybody else, make sure you raise your hand to see whose Pi is up and running. So, all right, awesome. Most of you have your Pi up and running. I am going to put all your hands down. So, like I said, this is your 4th class. And we're going to make it, this one is, again, starting to get into more sensors. And then next class, we're going to talk about integrating some. So some servos and things like that. And hopefully get into some integrations along the way of that. So let's continue on and let's recap. Again, I like to start off every class with kind of an agenda of what's going on and walk through that agenda so we know what's coming up, and so not any surprises too much. So again, we're going to recap, ask you some questions on some terminology about electronics, and we've been going over 3 classes now. We're starting to have some base of how to build more complex things. We went over an LED. We went over and a photoresistor. So now we can start to integrate them too as well. And now we're going to introduce you a new sensor, which is going directly on our robot. So again, we can use this on our robot or for other things. So we're going to talk about the electronic sensor. We're going to talk about the nature of an ultrasonic sensor, or in nature, what animals use ultrasound and the ultrasonic sensors in their ears, applications and actuators and sensors. It's actually a both. It's not just a sensor. An ultrasonic sensor is ultrasonic is actually an adverb, so it's describing a noun. So the sensor is a noun, but it is also an actuator, which is really cool. It's a combination of that. So if you look at that, that's one reason why there's 4 pins on yours. Then we're going to talk about coding, and it's a little different because we have to do a little bit of math behind the code this time. And then we're going to talk about physical hookup and see what else we come up with. So today, what you need for today's lesson is relatively simple. And if you have a tape measure, a ruler, or even an 8.5, something known of distance, like a sheet of paper, which is 8.5 by 11, you can use that as well. But you don't necessarily need a ruler, but it is very handy to have one. So when let me show. I'm going to scroll on over here, and let me see a raise of hands. Who has the ultrasonic sensor? The Arduino, 4 wires. Again, we're going to stick with, and I'm going to be more talking about the black being the ground, the red being the voltage or hot, and communication wires as a yellow and blue in this term. So let me see a raise of hands. Who has all of this? So if not, you can listen on and just make sure you get all of this because we will be using all of this together today. So again, we have the ultrasonic sensor, we have the Arduino, we have the half breadboard, and we have 4 wires. Again, raise your hand if you have all of these. So I'm going to remind you to raise your hand if you have all of these. If not, make sure you can get them now. This would be the perfect time to get them as we're kind of reviewing. So, reviewing and questions. So, this is where we gonna propose any questions. Looks good. Was I supposed to get an ultrasonic sensor in the kit? Yes, Austin. Let me unmute you. Austin, how are you doing?
Good.
You don't have an ultrasonic sensor.
No, I didn't get one.
You did not get one.
No.
Okay. We have to ship one to you. So quickly. Because let me write this down so we can get you one as quick as possible. So you have it for next time. For right now, the best you can do is write the code and follow along if you don't mind, Austin.
Okay.
Uh, Johnny, Austin. I'm gonna mute you. Johnny didn't get one either. Johnny, I'm gonna unmute you. Make sure that Johnny, how you doing?
I actually just found mine in the box.
Ah, just found yours in the box. Awesome. All right, Johnny. Thank you very much for being honest. So, if you don't have your ultrasonic sensor, it should be only Austin that does not have uh, his ultrasonic sensor. I'm going to give you a few. Brandon has it. Good. Austin, if you can take a look in your box again, just to make sure we did not misplace it, because from what I understand, we did everything and the quality check was there, but we could also have made a mistake. So, again, get your ultrasonic sensor if you don't have them, and we'll be talking about reviewing now. So, again, what part of the Arduino is this? I think we've asked this before, so I'm going to lower everybody's hands. And what part of the Arduino is this? Raise your hand if you want to take a stab at it. So, Brandon, I'm going to unmute you. Brandon, what part of the Arduino is this?
That is the those are the analog pins.
Analog pins. Perfect. Thank you, Brandon. I'm going to mute you. Great job. Great job. Again, this is to keep you fresh and to be intelligent about when you're speaking to each other and another person about your Arduino. You don't want to say this, oh, this goes in this thingy right here. That's not the smartest way to talk. So you want to be intelligent about that. And these are just review questions again. So what does serial mean? This was from last time. So this is in the void setup. So what does serial mean? It's initializing something. So I'm going to lower your hands and I'm going to ask that. What does serial mean, Jacob? I think I saw your hand first. Jacob, how you doing?
Pretty good.
All
And
right.
I'd say that the serial would mean starting serial communication.
Perfect. And that's analogous to anything that you can think of. Uh, that's analogous to, say, I want to speak Japanese or I want to speak English to you. So it's setting that parameter and saying, hey, talk to me through serial ports. And the Arduino only uses serial ports, from what I understand. I know that there's I believe there's some other ones, some other communication tools possibly, but they have to be communicated through serial. Using an FTDI chip is actually built into the Arduino. A little bit more information than you probably wanted right now, but yes, serial is there. So, what does PRINTL mean, and what does it do? So, what does PRINTLN mean, and what does it do? So, raise your hands if you want to take a stab at that, Corey. Corey, how you doing?
Nicely. So,
Awesome.
serial is the communication. Print LN essentially says incoming transmission, to use a Star Trek analogy, and it will print the line that you request. Analog read light pin means print LN of analog read of light pin means print the measurement on the photoresistor. In other words, print the light reading.
Great. Yes, and that's specifically for the photoresistor. Thank you, Corey. I appreciate that. to add to that, that also the print line, at the end of that, you will hit enter, so the next print will go on the next line. There's actually one today we'll talk about just print with no ln, and that just means it'll print, and then it'll print the next line right on the same line. It'll print the same object or the same code, basically, on the same line. So we'll be using that as well. So again, what does this symbol represent? Again, this is review. And if you were paying attention quickly, I ran through some of the schematics last week, but it is very good because to think about this in terms of not just being able to look on physically, but also be able to abstract this. So these symbols represent a physical object. So what does this symbol represent? I'm going to show a raise of hands to who wants to take a stab at what do this symbol represent. Jacob, again, nice job. Jacob, what symbol does that represent? Jacob, you there?
A photoresistor.
A photoresistor. Awesome.
Can you hear me better now?
I can. Thank you, Jacob. I appreciate that.
All right, that's good.
Jacob, I'm going to mute you, and I'm going to lower your hand. Yes, that is a photoresistor. And, you can tell it's a resistor, but you say, oh, built on it. It's very, engineering is very logical. And it's kind of like when I studied Japanese, it's a very logical language to understand. It's actually easier than English if you were to know certain things, because it builds on one. The characters build on it, just like the symbols build on it. So if you notice in this where my arrow is, or my cursor, this is a resistor. So this, and that's a squiggly lines, you can determine that it's this symbol that I asked about is some sort of resistor, because there's still a squiggly line. And then you can say it's kind of some input device because there's arrows pointing into it. So it's inputting a resistor somehow. So it's a sensor, and it's a resistive sensor. So again, it's a light sensor, photo sensor. Great job. So now what is pin mode? What is pin mode? And this is still in the initialize section. This is still in the setup. So you're initializing these pins. So what is pin mode? Show me a raise of hands to see who wants to take a stab at pin mode. Anyone? Brandon, I'm going to unmute you. Brandon, you want to take a stab at what pin mode is?
Okay. Pin mode is saying whether or not that pin is an input or an output.
Yes, absolutely. Thank you, Brandon. I'm going to mute you. I think you muted yourself, and I'm going to lower your hand. So pin mode is, it sets the pin first, and then it says it's either input or output. The beauty of this little Arduino is that I can set this as an output. I can set not any one of these pins, but I can set a lot of these pins as input or as output. So and this is the way to initialize that. Nice job. So let's start with some physics and stuff like that, so we can continue on. So ultrasonic sensor. Ultrasonic sensors are used in bats. Bats use them. If you know how bats work, they're phenomenal creatures. They're kind of creepy creatures, but phenomenal creatures. I was in Austin, I think, and they're known for their bats. Actually, you sit on a bridge, you stand on a bridge. I was actually at an engineering conference, and at night, they sleep under the bridge, and at night at dusk, they all go, and there's thousands of them. And the reason why I bring that up is because the coolest thing is they can't really see well with their eyes. So their photoresistors basically are they don't see well, or they're photoreceptacles. But what they do is they hear phenomenal. That's why they have such big ears, and they're using ultrasound. And so what it does is, and one reason why I bring that up is because if you imagine the control of that, if you had 1,000 quadcopters buzzing about, you think any one of them would hit another one and then hit another one and hit another one? No, that would be very catastrophic. But the bats are so attuned to this, and they're much better than any sensors that we have out now, but much attuned to this, so they don't collide with each other, and they're in groups of thousands. I've seen it. It's amazing. I've stood on the bridge, and all of a sudden you hear this, and they just come out of the bridge and just go somewhere for the night. They party or whatever they want to do, and then they come back at dawn, which is incredible. It's a fascinating experience to take a look at if you're ever in Austin, Texas. So again, that's just one thing in nature. Also, whales use them. So what they do, if you're not familiar with ultrasonic or ultrasound, what it does is you need an actuator, and that actuator is just kind of like a muscle, and it makes a sound. And ultra meaning it's beyond our hearing, so we can't hear an ultrasound. We hear about 20 hertz to 20 kilohertz, uh, and anything above that we cannot hear. Dogs can, but the way we are here usually, we cannot hear. The normal human cannot hear above 20,000 hertz in a frequency. So what that is it's beyond that frequency. It's faster than that frequency. The actuator shoots it out, and it goes on out. And then when it bounces off of something, it comes back, and you need these big ears or these devices to actually hear. So that's the sensing part. So an actually ultrasonic sensor is two parts. It's an actuator, so it sends out a signal or it triggers a signal, and then you receive it back. Again, that's how bats hunt. That's how bats find things in the dark. So ultrasonic sensors work in the dark, which is cool. But they won't. Sometimes you can think about it as, or if you think about this, you can see through a door, like a glass door, but the ultrasonic can't hear past the glass door, but you can see it. So that would be one thing that a photoresistor maybe could do, see through glass, but an ultrasonic cannot. But the opposite is, if you turn the lights off for a photoresistor, you can't tell much, but you can still hear. This is a drastic difference from the difference between sensors, and not one sensor is better than the other, but it's more about what use they are for. So again, I'm going to continue on now. So if you can start your Arduino and hit enter. And I'm going to see if anybody has any questions now. Let me see. Don't dolphins use ultrasound too? Yes, I think they do. I think they do have an ultrasound. I do believe, because they give off that and they have ears as well for that. And also speaking, to note that sound will travel differently in different environments. So it travels differently in the air. It does, and it travels differently in liquid or in space. Well, you can't really hear anything in space, so it doesn't really travel in space. Yes, Ari, it is bigger than you expected. Don't the majority of deep sea animals use ultrasound? I believe so. That's a new one on me. I'm not very familiar with that, but I would assume so, or some other sensors, because what that does is that you can't really see down there, but it will travel fast. I believe it travels in water. It travels. Sound travels 4 times faster than in air. That's one reason why if you're underwater and you snap a finger, you can't really tell which direction it came from. But if you were to be in a room which is dark, and you snapped your finger, you can tell what direction it's coming from. Your brain senses that. But when you're underwater, it's not so much. So they got to be very, very much so yes, Jacob, sound doesn't travel in a vacuum-like space. That's what I was saying. It doesn't travel at all. It travels in the spaceships, but beyond that, it doesn't. Because what's actually happening with it's a sound wave, and the wave actually pushes and vibrates the molecules, which is real cool. It vibrates the molecules in the air or in whatever medium you're using, which is fantastically simple. So my first picture was taken with an ultrasound, Corey. Yes, your first picture was taken with an ultrasound. Absolutely. Mine was not. I'm a little older than you, but yes, your first pictures was taken by an ultrasound. And I have kids, and they have their first pictures was taken by an ultrasound. Good job, Corey. Yes. So let me run. Oops, getting a little lost here. So we got to the Arduino. So again, we're going to write our code here, and I'm going to bring up so I can write my code along with you. So let me see a raise of hands. Can you still see this screen? Let me see a raise of hands if you can still see this screen fairly well. All right. All right. Good, good. All right. I think I'm going to stick with this for now. Maybe pull it apart, maybe pull it over and drag it up to make it a little bigger. All right. I'm going to lower everybody's hands. So let's see. If you are, we want to write your code and bring up the Arduino now. So let me make sure everybody, give me a raise of hands to make sure that we can start writing code now. I think I have to speed up. So, all right. So again, let me show me a raise of hands. Who can start writing code now? And Austin, good, 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 good. 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 All right. Now let me run through some of this. So let me scroll through this. Again, we're going to start the code with some sort of communication for humans. Again, this is not for the computer to read, and anything in between these characters, which is a / and an asterisk, and then the end would be an asterisk and a /. Anything in between those characters do what in the program? They do nothing. They're only for humans to read. So we can communicate our code and say, hey, this is using an HCSR04 ping distance sensor, yada yada yada. So this is what we will be using, and this is a code that I took from this place at I forget where actually I had it. It's in the resources, I believe. So let's start continuing on, and let's see some new stuff. So this is new to us, so we do want to put this in our code. We want to put the number sign, which is shift 3. We want to put define, and then we want to name it trigger pin 12, and then we want to name the other one echo pin 13. And just to let you know that the number symbol and then define is borrowed from the computer language C, which is actually Arduino is written in, and it's a pseudo C, I'd say. And we set that constant. And this is, make sure we do this differently. So one is on pin 12 and the other one is on pin 13. So this is different from what we normally do. And we normally set it just as an int we've been setting. But this is, we can put, we can do this because it actually understands C as well. So I would do that first. We have a number define trig pin 12, and that trig pin is short for trigger pin. So eventually we will connect the trigger pin to pin 12 and the echo pin to 13. Do we need a new circuit, Ari? Yes, this will be a completely new circuit, and we'll get to that in a second. Good question. So we keep coming in, and again, that trigger pin is for 12, and eventually it will be, we will connect the 12 pin to the trigger pin on your breadboard, and then connect the breadboard to your ultrasonic sensor. And the echo pin the same way. And make sure one is 12 and one is 13. So I'm going to lower everyone's hands now and continue on. We will continue on with the echo pin 13 as being our last one, and then we are going to, why else? Let's see, what else is different from how we normally set these constants? So let's take a step back and take a look and ask that question to you all, if you can raise your hands, to what else is different from how we normally set the constants Ari, I think you had another question, and I'm going to unmute you. So while you're stirring that and thinking about that, I'm going to unmute Ari and see if he has any further questions. Ari, how you doing?
Well, I'm alright, but I don't know because that last slide of code you showed, I didn't really get much of that input.
Oh,
Do you
that's
need
all
that?
right. That's comment code. You don't really need that. That's just comment. You can put anything in that comment code. So
Oh, okay.
now when you start defining it like this is where you really do need to do. And again, what I'll do is we'll run through each line of the code, and then at the end I'll post it again for you. So if you missed anything, um, it will be up. And if you have any questions about anything, make sure you raise your hand. So anybody, I'm gonna show a raise of hands now. And what else is different from how we normally set? Not just the number defined, but what else is different? Jeremiah, I'm gonna unmute you. Jeremiah, what else is different? Jeremiah, Jeremiah. Hello, Jeremiah. All right, I'm gonna mute you. Anyone else? Anyone else? Eachin. Man, Eachin. Eachin, how you doing?
Okay, and I'm not sure. Is it that we don't put an int there?
Yes, that's one thing. That is very different. Yes, but there's something more towards the end. So I'm gonna mute you and give Corey Corey.
Well, I think that it's the fact that we don't have an equal sign, like, how we do var something equals something.
That's true. Yes, that's also true. So there's very different syntax, but it gets the same thing done, which is um, which is another thing. So what else is different about this code? Jeremiah, let me see if you unmute you. Jeremiah. Jeremiah. All right, I'm going to mute you, Jeremiah. And I'm going to lower everybody's hands. What else is different is that there are no semicolons. Again, there's no ints. And like Yichin said, and then Corey also pointed out, there's no equal sign. So those are different. And in different languages require different syntax, not to be confused. But in Arduino, it will take multiple syntaxes, which may be confusing at first. But once you understand that why they're doing it, it becomes pretty apparent, and you can switch back on code. I know when I don't code much anymore, but when I was coding in college and for grad school and stuff, I could read Java and C++ and HTML, and I wouldn't even have to think. It's kind of like learning different languages, which is actually real cool. Uh, so um, let me, Jeremiah, you can't hear me? I can't hear you either. Maybe there's a connection on. Let me see a raise of hands to make sure everybody can still hear me. So raise your hands if you can still hear me. Getting some. Okay. 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 It must be Jeremiah. He's just offline. Um, all right. Thank you for that pause. Let's continue on. So again, what is void setup? And since we're kind of running in time, and I want to get this done or quickly, we're going to bypass that, and I'm just going to tell you the answer. So setup is a function which starts when the program is run, and void means return nothing. So again, uh, it initializes all the variables. So we're going to set some stuff here, like setting the pins and starting using the library. So we're going to do that today or in the coming future. So let's continue on void setup. And if you don't get it, any guesses to what to go in the setup? Well, we just talked about that. Initializing again, it's getting a little past, it's 6 o'clock, so I want to keep going. So let's continue on, and I'm going to answer that. So we start to initialize things like pin mode and other variables and our serial communications and things like that. So again, let's start by copying this code, void setup, parentheses, your open curly brackets, serial, and make sure that serial.begin serial is capitalized. So I'm going to actually do this while we're doing this, and I'm going to create a new sketch. Actually, here, that's the code, but you don't need to see all of that yet. So we can continue on, and we can go on. So void setup. Again, what I'm doing here is if you see it's orange in there, that's a good thing. If you don't see orange, you misspelled something. So let's keep continuing on. Serial.begin. And I spelled that correctly. Sometimes I don't. So again, don't forget your semicolon, which is highly important in this. So let's continue on. Let's review. Serial does mean the type of communication begins, sets the speed of the communication, and 9600 is the speed of our communication. So this is the next function, or the next thing we can take a look at. And this is pin mode, and this is our trigger pin mode. And we're going to set that to output. So again, if pin mode is not colored orange, you did something incorrectly. Again, if output is not blue, you spelled it incorrectly. Now again, it doesn't know if this is input. Like I can put, don't do this, but I can put high, and that high is blue, but that's not the right one. We're not setting it anything. We're just initializing it and saying, hey, what is all of this stuff doing? So I spelled output wrong. So, and it must be capitalized, and don't forget your semicolon. So again, your code can look like this. So, okay, Jeremiah, good. You can hear me now. Awesome. Now again, now the next one, we can do another pin mode, and oh, I'm not on that slide. So we can pin mode, and then we do an echo pin. So the first one was the trigger pin, and the first trigger pin is the actuator saying, or it's actually, it's putting out the ultrasonic sound, or it's putting out the ultrasound. So again, the ultrasound means it's higher frequency than our human ears can hear, and that's the output. So the pin will output that, and it'll send the signal and say, "Hey, actuator, do this." When we actually tell it to do something. Excuse me. Then the pin mode, echo pin, it'll say receive this, and this will be the input. So again, let me do that for pin mode and echo pin, and this has to be initialized as we said before. And I'm going to go ahead and I didn't define anything, so number define trigger pin, trig pin, and I think I set that to 12. I do forget. And then I have the define echo pin, and that is 13. So let me see if I did that correct. I think I did that. Oh, and well, anyway, I'll catch up anyway. So again, that is it for the pin mode and the echo pin, or the echo pin. So this is what it looks like now. So we have void setup. We have the pin mode, trig pin output. Comma output, and the output is capitalized, and then the next and semicolon, and then we have the pin mode, echo pin, and it's a comma input. So we're done with initializing everything. Now we go on to the kind of the we're gonna go through the bulk of the program now. We're gonna do again. I'm not going to talk about that. We know what a void loop is. We've talked about that over and over again the past 3. So void just means it's not going to return anything. A loop means it's going to keep going and going and going and going and going and going and going until you can't, till it has no power left. So let's continue on. So again, we are going to create 2 local ints, duration and distance. Basically, to let you know, and I'm not going to go too much into it, but we were setting global ints before, global variables before. Now we are, and that just means it's anything can use them in the program, or any function can use them. Now, if we couldn't use duration or distance inside the setup, because they're not part of the setup or part of the program. They're part of the function, which is part of the program. So it's, I don't want to get too confusing now, but just to let you know that int duration, comma, distances are setting to local. So they're local to the loop. One is duration and one is distance. And what's going to happen is the duration is the time it's going to take for the sensor to the trigger to output something and for the echo to receive it. So it's going to output something and it's going to receive it. The ultrasonic sensor. One is the duration, so that's the time. And we're going to do some calculations to figure out the distance using the speed of sound in air. And that's where some of the math can come in handy. So, should you save it? Yes, you should continue to save your stuff as we continue on. So again, now what we're gonna do is we're gonna say what that trigger pin is doing. So that we're gonna digitally write to it. So it's not an analog sensor; it's a digital sensor, and a digital actuator. So it's either on or off or high and low. So again, it's a digital write, and that W is capitalized. So I'm gonna continue on down here, and I'm going to do my own int duration, comma, distance, semicolon, digital write. And you know if you wrote digital write correctly or not because it turns orange. So the sketch IDE or the development of it is fairly, it's kind of smart because it'll know if it recognizes that function. Now it won't recognize the trigger pin, and it will recognize that it will turn on or off. So digital write, trigger pin, comma, high, and high is capitalized. So again, we're going to put a delay in there. So we're going to delay this, and we're going to delay this in microseconds. There's different ways to do this, and make sure, again, you spell that correctly. And we're going to pause here, and I'm going to ask a question. How many seconds are in 1,000 microseconds? Anybody? Jacob. Jacob, how you doing? Jacob.
Pretty good.
Good. So how many seconds are in a 1,000 microseconds?
1,000 microseconds. That's 1 second, right?
Yes.
Or less than one. Yeah, 1 second.
1 second. It is 1 second. Thank you. Thank you, Jacob. Great job. Great job. Yes, it is 1,000 microseconds in 1 second. So we're going to delay this, and we could delay this. Tell the truth, I don't know why this program's doing this, but we can now. It just shows you another code. That's why I left it in there. It shows you you can also delay, which defaults to microseconds, or you can delay in microseconds. Now, I don't know if Arduino actually says delay in seconds. I've never seen that, and that's a possibility. You could fool around with that later on. So again, let's continue on with delay. So now what we're going to do is we're going to digital write trigger pin low. So we're going to delay, we're going to digital write. So what we're going to do is we're going to turn it off now. So we turn it on, we turn the trigger pin on, and then we turn it off, right? So we turn it on and turn it off. That's all we're doing. So we're digital write. Again, if it's orange, it's good. If it's and it's also blue, it's the low, or the color of the low. So make sure you capitalize that. Again, when you're writing code, sometimes you get discombobulated and you forget. But anyway, to do a higher and low in capitals, and sometimes the Arduino can catch some of it, not all of it. It's not going to catch all your errors, but it will catch some of your errors. Let's see. What question, Corey? Why is a millisecond a thousandth in physics and microsecond is a thousandth here? That's a great question. That's a great question. I think I'm wrong, Corey. You wanna say something to that? That's a great observation. I might be wrong.
So a microsecond is a millionth of a second. 1,000 of them is a millisecond.
Great job. Great job. And I do stand corrected. Corey is correct. 1,000 microseconds is actually 1 millisecond. For some reason, I got a little confused there, which is great. Thank you. Thank you. I appreciate that. And if you see anything else wrong, please let me know. That's awesome. Again, I'm running through this, and sometimes we make mistakes. Great job. Great job. Awesome. So, digital right, trig pin, comma, low. So make sure you have that, and then we continue on. And then what we want to do is we want to measure the duration, or we want to not measure duration. We want to put duration, and duration is an integer set to this. It's pulse in, which is actually a function, and I'm going to go through here. Pulse in returns a pulse time in microseconds that the echo pin is on. So it's receiving this. The echo pin, we turn the echo pin on, and it's receiving this high-low. It's digital right is on, and it's receiving what the digital trigger pin is. So actually, that is the total time that it's going to take for the ultrasonic sensor to send something out, and if it reaches something or hits something, and bounces back. So this is called this is a pulse-in function, and it is actually a function in Arduino. Thank you, Arduino. So we didn't have to write our own code. Some of this stuff is great because we write our own function. We don't need to write our own functions. We can use them. If we want to tweak those functions, we can write our own functions, which I've done as well. Sometimes they're not as good as I'd hope, and elegant as I hope, and I have students that do the same. So again, so should we leave it turning off after 1 millisecond? 1 millisecond. No, we're talking microseconds. So leave it as the code stands still. Good question, Austin. Good question. Austin asked, so we should leave it at turning off after 1 millisecond. Leave it as B. This is the code that works. So I've tested it, and the code does work. So again, the pulse in is actually the pulse time in microseconds, and if you notice that little mu symbol up here, that is microseconds. So sometimes you'll see that, and it is borrowed from the Greeks. Thank you, Greeks. They helped us out in engineering profusely. More than you know and more than I know. They helped us out with a lot of stuff that we know, and it's good to know some history about that. So continue on with the pulse in and the echo pin. Turn that on. Now, and it records the time, which I talked about, for the pulse from the trigger pin to leave and bounces back to the echo pin. So again, it's going to measure the time, and I don't want to beat a dead horse, but let's continue on. Now, this is where we gonna change that time, and now we have time, and we gotta figure out how to get distance out of it. So what we can do is we can set the distance, and this is what's going to be the distance between the ultrasonic sensor and the object that that we want to measure the distance from the ultrasonic sensor to an object in front of it. The object could be we're going to set it up to 20 centimeters, and it can't go below 0 centimeters, and we'll talk about that in a conditional statement now. So again, that distance is the distance, it will be the distance that the sensor and the object. So again, that distance relies on a duration. So basically, in algebraic terms or math terms, distance is a function of the duration. So the duration, make sure you spell these correctly, because if you do not, you will get an error in your code. So again, make sure you spell them correctly. So the duration divided by 2, mainly because we're dividing the time by 2, because it takes the time from the actuator to send it out and come back, and we're assuming that we're going to cut that in half. Now, that may be a big assumption in the future, but it's pretty good for now. And I've measured it last night. It's just slightly a little off. And I didn't get time to fool around with it, but you can later on. And the 29 now. So why do we divide this by 29? This is the speed of, so this 29.1 represents the pace. So it's actually the inverse speed. So this is the pace of the sound. The inverse of speed of sound is measured in microseconds per centimeter. So what's going to happen is the microseconds are going to cancel out, and you're going to be left with centimeters. And centimeters is a unit of distance. Let me see if anybody has any questions. Metrics are English. This is metric. Are spaces optional? Yes, spaces in between here. The equal sign are, yes. Or is it proportional? Let me, Corey, I'm not understanding that. Let me unmute you. So be ready to be unmuted and ask that question. So, Corey. All right. So, what is the question you were asking?
It was metric or English, but then when you explained microseconds per centimeter.
Yes. So that answered your own question. Good.
Yeah.
Awesome, Corey. Also notice that if you ever see an S as a unit of measure of time, that is a measure. That is the unit, the symbol for time, as in seconds. Now, in the British or English units, as you call that, SEC is the symbol for seconds in the British units. Corey, I think you have another. Got it now. Thanks for the explanation. Awesome. So I'm gonna list you. Let's continue on. Make sure that 29, and again, that is the pace of sound. So again, if this was underwater, which I'm not saying that we want to do anything underwater right now because it's kind of dangerous to stick this underwater, and don't do that, please. But if we were underwater, we'd have to change that variable. If we were somewhere else, we would have to change that variable. If it was foggy in the room, we would have to change that 29.1. So this is just what we have now. So let's see here. Therefore, I already talked about that. Now we're going to talk about, we only have about 12 minutes, so let's get through the if statement. I don't know if we're going to get to hooking the ultrasonic sensor up, but let's get the code at least. And I think Corey had another question. Do you have advanced math for how sensors works to post? Yes, I do, and I'll post that. Some of the stuff you can find on the internet is pretty good. Now, I hope, not I hope, but I think you're talking about the ultrasonic sensor. Yes, there is there, and I'll search for them. That's a good question. So we're going to write an if-else statement, which is new to us. Please do not write the conditional statement. This is just something that you know something's going to go in there. And this if-else statement is a conditional statement. And this is very similar to the one you're doing in Scratch. Very similar to the one you have to use in Scratch. So if you're use the if, don't put the conditional statement or the brackets, not the brackets, but use there. Let's delete this so you can see what I want you to put in it. Right now, do this. So again, you don't have to write some code goes here. You can, but make sure you have the if statement, the parentheses, the open curly brackets. Hit enter twice. Go down to the close curly brackets. Then you hit enter once, and you hit the else. Then you open the curly brackets, and then you close the curly brackets. So if we do, Austin asks, so if we don't get to hook up the sensor today, I'm not behind. So that, yes, Austin, you are correct. Let's get that sensor to you as quickly as possible, and you may not be behind. That works out well for you. So again, write this into it. This goes actually in your setup. So again, this if statement goes in. I'm sorry, not your setup, but your loop. Make sure it goes into your loop. So let's continue on. So let's put in the parentheses. We want to put this, and this says we want to say the distance is greater than or equal to 200. Distance is less than or equal to 0. So that's what we want to put there. So we know the limits of the ultrasonic sensor. So if it's beyond 200, and actually this sensor, anything beyond 200, it's not really going to catch it because of error at the end of that. It gets what's called nonlinear at that point, and it really has a lot of errors involved at when it gets even at 200 centimeters. It's not as good as it is basically almost a foot away. So let's see if there's any questions. Ari, are we putting this in now? Yes, you want to keep putting this in now. Absolutely. So again, follow along. That's awesome. So again, distance greater than or equal to 200. Now, what does these two parallel vertical lines mean? Corey raised his hand real quick. What those? Corey.
In logic, inexclusive or means you have one, the other, or both. And that's inexclusive or, as far as I know.
Absolutely. Corey, great job. You're a smart guy. You know that. So that does mean or. So for our intents purposes, it is an or symbol. So basically, it's saying if the distance is greater than 200 or it's less than a 0, do this. So again, what is it doing? We want to set our lower limit, and what's it doing? We want a serial.print out of range. So we want to know when we're out of range here. So again, the serial print. Remember that serial dot PRINTLN. Remember the LN. So it's a print line. So again, after the E in range, it's going to hit enter, and it's going to go down to the next line when we use the serial monitor to do this. Again, serial is capitalized, and it's a dot print LN out of range. And remember the semicolons. Semicolons, I don't know how many times. That's a good question, Ari. No, it's not forward. This is it's not a forward slash. It's going to be shift on mine is above the backslash. So that vertical line is probably going to have to shift something on your keyboard to hit the parallel lines. That's a good question, Ari. Good question. So let's continue on. And we're getting to kind of the end of the program. So what is print? So notice the difference from print L and so let me see a raise of hands to see what is print. So who knows the answer to just print? Jeremiah, you're back on. Jeremiah, how you doing?
Good.
Good. What does print mean?
It means that it's like print line, but it won't end the line when it's done.
Absolutely. Thank you, Jeremiah. Great job. I'm going to mute you. Lower your hands. Yes, Jeremiah is correct. Serial.print. Make sure it's not print line, or else when humans can read it, it's not going to be that readable. This is the cleanest code. I shouldn't say the cleanest. This is the cleanest way that I've seen it used. You put the distance, and you put a space, and you put cm, which stands for centimeter. On the next line. So there's serial.print. Then you put distance in between the parentheses. Again, don't forget your semicolons. I don't know how many times I forgot my semicolons, had to go in and hit the semicolon for this case. Then what we want to do is notice that the distance is actually the variable we set earlier, which is what we want. So basically we're setting this, and we're letting our ultrasonic sensor, when we do the serial monitor, to actually read how far the object is in front of us, which is incredible. That's awesome. So now you can think about, you think about a robot. let's use a typical robot saying, hey, if it gets too close to you, it backs up. Be like a scared dog, or the opposite. Say it gets too close to you and it starts running towards you, which is like an attack dog. So you can do either one with this, and that's kind of the logic that can go into this. So it's really cool. And again, bats use them very more complex than this ultrasonic sensor that you have, and we are not there for technology at any means. Biology is so far more advanced than any technology that we have on the planet. Although we do have rocket ships which are faster, but they are more complex and they do take a lot of maintenance. And I'm getting off track here. So again, the distance, and make sure, since the distance is measured in centimeters, we can set the units. Also note that this is for human communication. This cm is for human communication. The computer doesn't care what it is. It's just going to output what you tell it. And again, remind that is a print line. And again, we have 4 minutes, so let's kind of speed through this. So the code, and then after the else statement, we have a delay. So the delay is 1500 or 1.5 seconds, or 1500 milliseconds, or 1,500,000 microseconds, as Corey pointed out before. So we want to put a delay in there. Now, let me roll through and where the heck is, all right, where are the keys you press to make it again? So let me, Anne, I'm going to unmute you and ask that question. Anne.
Yes?
How are you?
Good.
Good. What was the question?
I don't understand how to make the parallel line symbol, the or symbol.
Did you get it or no?
No. What are the keys you press again?
Well, I'm running a Mac, so mine may be different, but it also could, you see the backslash line on your keyboard. So the backslash line, and above that, what does the backslash line look like? Does it look like two vertical lines, basically?
Yes.
Okay. Shift, hit that twice.
Okay.
You got it?
Okay.
That's a great question. I kind of ran through that because I think a couple of you had that question. So again, I'm gonna mute you, and thank you for the question. And I'm gonna raise your hand if you have any other questions. Because it's 6:28, and I think I'm gonna end here. So if you have any questions, Ari, anybody else? All right, Ari. Ari, you're muted. You're muted on your end. Ari, how you doing?
Well, I was wondering if we put 2 forward slashes before if, because it had that on one of the previous screens.
It did. Let's see. If it did, I didn't mean that. Oh, I see. No. Okay, I see what you're saying. No, it just says the if statement goes here. No, you don't put the two slashes in there.
I have another question.
Awesome. Yeah, keep it coming.
What about pulse? Is it IN or LN after pulse?
Pulse in, IN, capital I. That's another great question, Ari. It's pulse, capital I, lowercase n. Yeah, that's a great little detailed question. That the L and N, the capital L and the lowercase, the capital I and the lowercase l look very similar. That's a good question. So it would be pulse in. What keys? Let me lower your hands. And anybody else have any questions? It is 6:29, and that's it with the code. I think once you get that, yes, the whole loop looks like this. So again, it is 6:30, and we did run out of time, but we'll catch up next time. We'll hook up the sensor and we'll start into servos. So what we can do is really cool with this. So I'm going to stay on for another 5 minutes or so to see if anybody has any questions. If not, It's 6:30. I had fun. I hope you did too. I'm really excited about the ultrasonic sensor because you can do a lot of cool things with it. So I will see you next Monday. Have a good weekend. And I'm going to mute you if you have a question. So I know that you're still on. Ann? Ann?
What?
Are you? I was wondering if you
I don't have a.
you do or don't.
I don't.
Oh, okay. Okay, good. Joel, I'm going to unmute you to see how kind of class went. So, Joel.
Hey, it's looking really good. Everything. I'm actually uh, meaning to send you. I wrote up. Remember last class we were talking about just some feedback, and
Yeah.
I wrote up some feedback, and I found out our email server was having some issues because it didn't upgrade with outgoing and ingoing messages. So I saved it instead of sending it. So I'm
Yeah.
gonna send it to you tonight.
Okay.
Because I really like some of the things you're doing. Thought you should know which things are coming out really well. Stuff like your questions and things like that. I really like a lot of that, and just had some other little feedback things, stuff that I thought I would just send your way. Oh, sorry, my doorbell just rang.
No
Um,
problem. Is it
but hey,
you got some
yeah,
time or you got to go?
I'm not sure. I do have company coming a little later tonight, but they won't be here till late.
That's quite all right. I got my sister coming into town from New York.
Okay. So hey, sorry, I gotta hang on one second here. Fiddling around with my audio here. I have another session open. I don't know if you know I have a Blackboard Collaborate session that runs concurrently to the class with
Ah,
my students in it that want to chat. We started that around lesson 6 or so. But yeah, I do got company. I gotta run, but
yeah, man.
I'll catch up with you first thing tomorrow morning. I'll send you that email.
Sounds good.
And if you want to call me tomorrow, I will be in my office all day. So
Yeah,
I'll talk to
looking
you.
for some feedback so we can improve it. So.
Absolutely, I got some good info for you, and I'm really digging the way you've got the code set up and things like that. But I got some like little things that just kind of pop in my head that I thought I'd just collaborate a little bit with.
Hey,
So I'll
man.
talk to you soon. All right?
That's all right, man. Thanks. I appreciate
All right.
that.
I'll see you. Bye.